So this is our final question for Unit 2 on equilibrium. So for this one, we must take into account pretty much everything we learned. This is the famous ladder problem, which used to be frequently included in provincial exams back when they existed. So we must remember that for translational equilibrium, we have sum of the forces in the x direction must equal to 0 newtons. We have sum of the forces in the y direction must also equal to 0 newtons. And sum of the torques must be equal to 0 newton meters. Okay, all these must be true for equilibrium to exist. So what's happening in this one is that the key thing to be happy about for this question is we're given that we're told that the wall is frictionless. The reason this is important is if the wall was not frictionless, the problem would be a lot harder. So what we can see here is on the wall there's just the normal force pointing out. The ladder itself has mass, so that's a force going downwards. However, we look at the ground exerts a normal force upwards, but also we can see there's a force of friction force to the right. So Fg is actually up and to the right, this angled vector. So if we do not say the wall is frictionless for this problem, this question would be significantly harder as the force would also be at some angle. So let's solve for this one. Sum of the forces in the x direction. We can see that we have two forces, Fgx and Fw. So I'm going to define up as positive and right as positive. Also, I'm going to define for this question that the clockwise direction is positive. So what we're going to write in is, okay, we have two forces. We have Fgx. So it's a positive value because I define right as positive. And minus Fw. So there is our first equation. Fgx minus Fw is equal to 0. So when we simplify this, we see that Fgx is equal to Fw in magnitude. So there's our first equation. The next one, we say, okay, what forces do we have? In the upwards direction, there's Fgy. However, we see Mg is in the downward direction. So this equation is going to simplify to Fgy is equal to Mg. There's equation number 2. Lastly, we're going to get an equation for torque. So this is where pivot points become very important, because what we need to remember is that the location that we choose the pivot point will either make our question a lot harder or easier than it should be. So I'm going to place the pivot point right there. Here's my pivot. The reason we do that is because wherever you choose the pivot point to be allows us to ignore the forces at that location. The reason why this is a good one is because we can see that there's that Fgx and Fgy. So when I'm putting the pivot point there, I only need to worry about Mg and Fw. Again, the reason why we can ignore those forces is because torque is equal to force times distance. In this case, that Fg is a distance of 0 meters from the pivot. So anything multiplied by 0 is just 0. So they can be ignored. So let's write our equation for torque. So in the clockwise direction is this Mg. I want to find out what this distance is right here. Because Mg is going straight down. The ladder is not at 90 degrees with Mg. So what we need to find is the perpendicular distance from Mg. So it'll be pretty easy to find. We're given that the ladder is 5 meters long. And we're given the height right here is 4.0 meters. So 5 squared minus 4 squared is 9. And we square root that to get 3.0 meters from end to end. However, the distance right here is actually half that. So 1.5 meters. So we end up with Mg multiplied by 1.5 meters. So that is our clockwise torque. Again, it's being counteracted by some counterclockwise torque. The force creating that counterclockwise torque is Fw, and Fw again is not 90 degrees to the ladder, so we need that perpendicular distance, which is actually just that 4.0 meters. 4.0 meters. So we can go ahead and solve for Fw. Fw is equal to, we end up with mg multiplied by 1.5 meters, and we divide by 4.0 meters, and we get a value of, so our mass is 12 kilograms times 9.81 meters per second squared, multiplied by 1.5 divided by 4, and we end up with a value of 44 newtons. The question is, determine the forces exerted on the ladder by the ground and the wall. So we found Fw. So now we can say, what's Fgx? We created that equation before. Fgx must also be 44 newtons. Because we saw at the beginning that Fgx and Fw must be equal to each other. And Fgy, well, we can just solve for that. Fgy is just equal to mass times gravity, so 12 kilograms multiplied by 9.81 meters per second squared to get 118 newtons. However, leaving our answer like this is not good enough because the force we're actually interested in is Fg. So again, what we need to recognize is that Fgx and Fgy form a triangle. 118 newtons, 44 newtons, some angle. So we need to find out what Fg is. So Fg is equal to 118 squared plus 44 squared, square root. Let's get 126. So I'm going to round that to 130 newtons. I'm going to find the direction as well. Inverse tan 118 divided by 44, you get around 70 degrees above horizontal.